This is the last example for section 3.7 on implicit derivatives. And here we are going to find the derivative dy dx given that sine of xy equals x squared y. So we've got some stuff going on here for sure. If you look on the different sides of our equation here, on the right-hand side, we have x squared times y. And remember that y is a function of x in these problems. So we're looking for dy dx, y is a function of x. So this is a product of two functions here. It's important to identify that because that tells you that you are going to need to use your product rule on this. Okay, which is very important. And then you might notice there's another little product over here, x times y. So that's product as well, but that is also situated inside of the outer function sine. So this is a chain rule and a product rule over on the left-hand side here. So chain rule, because we have one function inside of another, and the inside function happens to be a product. Okay, and we've got a trig derivative with the sign there. It's a whole bundle of fun here. Okay, let's go ahead and get set up for our implicit derivative on this. We're going to take derivative with respect to x of both sides of the equation. So this is a good first step here. You're just writing down what you're setting out to do. And now we'll start applying all those rules. So on the left-hand side over here, we've got our chain rule and product rule that we're going to need to use. We'll start with the chain because we've got to take the derivative of that outer function and then keep the inside the same, multiply by the derivative of the inside. So chain time. Okay. So we are going to do this, and I will use the cover up process as I typically do to cover up that inside function just for right now. And so we're taking the derivative of sine, which is cosine, but just cosine of a purple rectangle for right now, times the derivative of the inside there, which is currently purple rectangle. Okay, so there's the chain rule setup. And now uncover and see that it's really xy that should go here and here. Okay. And let's go ahead and finish this left-hand side here by doing our product rule for xy. Okay, so bring cosine along. That one's done, no more derivatives to take there, but we do have to do this part. So we've got our first function times derivative of the second plus our second function times derivative of the first. So there's our product rule. And then we see what result that gives us. We've got x times dy dx plus y times 1. So just y there. Okay. Cool. Now let's go back up and pick up our right-hand side of this equation. It's going to be a product rule over here as well. Okay, just like we just did. So we'll have our first function times derivative of the second plus our second function times derivative of the first. There we go. So that's x squared dy dx plus y times 2x. Okay. And we'll just clean that up a tiny hair here x squared dy dx plus, I'd call that 2xy. Okay, now we're not quite done yet here because we have not actually solved for dy dx. So that is our next step. We got to get this guy, which has a little typo in it, dy dx, there we go, solve for on one side of the equation. So we need to loosen up some terms here. Let's distribute our cosine xy so that we can have more movement of terms. So x cosine xy dy dx, just distributing, putting things in a nice order there. And then plus y cosine of xy equals x squared dy dx plus 2xy. Okay, now the next thing you want to do is get all your terms with dy dx to one side of the equation. So I'm going to subtract this guy over to the left-hand side, and then move everything else that doesn't have a dy dx over to the other side of the equation. So this guy needs to get subtracted over here. Okay, when we do that, we'll have x cosine xy dy dx minus x squared dy dx when this guy came over. Okay, and then equals 2xy, and move this one, subtract over here, so minus y cosine xy. Okay, now we need to factor out our dy dx. Do that on the left-hand side here. We'll have x cosine xy minus x squared. And then just rewrite here on the right-hand side. I suppose you could factor out a y over here on the right-hand side if you felt like it. Not strictly necessary though. Okay, and then our last step here, just as I'm running out of room, is to divide on both sides by this term in the brackets here, x cosine xy minus x squared. And so we get dy dx equals 2xy minus y cosine of xy all over x cosine of xy minus x squared. And that is our derivative.